Now, the safety of structures involves the investigation into the scale of collapses and deaths from structural failures around the world, and this is significant. Somewhere every day, a building collapses or an engineered structure collapses, or there is a devastating fire. And also every day, there is news of more damage to our world from the climate emergency. Now, such events cause devastation not only to the victims and their families, but for those who have been involved in design and construction, and that includes us as engineers. So we need to have more concern about the impact of what we do. We have the ability to control the safety of structures and to influence the effects of climate change, although that's obviously an immense task. So we must be more concerned about how we take care of not only ourselves, but the safety of the communities that we serve. And a balance has always got to be struck between ethical behaviour and the drivers of financial gain, which often are of paramount consideration amongst those who employ us. But we can learn from failures and we can do better. CROSS stands for Collaborative Reporting for Safer Structures, and it relates to both structural and fire safety. Now, according to independent surveys, we're impartial, authoritative, and informative, but above all, we are independent. So we gather confidential information and reports about safety concerns and occurrences, and we depend upon groups of volunteer experts to provide comments and advice on the reports. The reports and advice are then published on our website. Now, as shown here, there are several factors which influence safety. And top of the list is to have an embedded safety culture, which is upheld by competent people who use quality systems in their work and have comfortable relations with appropriate regulators. This ideal, however, is often challenged by those operating the financial levers. So the timeline for CROSS, it began in 1976 when the Standing Committee of Structural Safety, SCOSS, was set up after several major building collapses and bridge failures. It was founded by the Institution of Structural Engineers and the Institution of Civil Engineers, and they were later joined by HSE, who came in as sponsors. The committee noted and provided advice about structural safety matters in the public domain, but came to recognise that there were many events which went unreported for various reasons. A principal one being that people, engineers, or their lawyers did not want what they perceived to be dirty linen washed in public. SCOSS therefore decided on a trial period of confidential reporting and used as a model a system used by NASA called Aviation Safety Reporting System. And the scheme was then called CROSS. At that stage, it stood for Confidential Reporting on Structural Safety. In 2021, CROSS expanded into fire safety, and this was a result of the dreadful fire at Grenfell Tower, and this will be detailed later on by Paul and Neil. But an important outcome for CROSS is that we were encouraged and supported by government to expand our structural activities, expand into fire safety. So in 2021, we were joined as supporters by the Institution of Fire Engineers. And the name then changed to Collaborative Reporting for Safer Structures, cunningly devised so that the acronym stayed the same, but we could now embrace any form of threat to structures. So the reporting process, handling reports is our core business, and we are interested in reports about the four main stages of the life of a building: the design, the construction, the operation phase, and the end of life. And we define a concern as something which is noted pre-construction and dealt with appropriately. An event is an occurrence which happens on site or during occupation, and there is physical evidence of some failure or collapse. Now, most structural reports come from the design or construction phase because that's where most of our reporters are at the moment. But in due course, we can expect more to come in the operational or occupational phases from fire engineers and those in the fire services. Now, the identification of precursors is extremely important in our work, and we use this risk triangle, which is of the same type which is used in medicine, is used in finance, banking, and so forth. Now, it's graded from normal operations through concerns, through events which take place during a process or operation, and they peak with occurrences which result in fatalities. Events in the red sector are certainly not to be reported across, at least in the first instance, when they are the responsibility of financial authorities, but everything, regulatory authorities, but everything below this level can be possible precursors. And if the danger signs can be recognized, they're vitally important for forecasting possibly more serious events in the future. So what are the benefits of confidential safety reporting? These are real. Some of them are shown here. And they start at the top. They make structures safer and ultimately save lives and reduce injuries, but also they protect the well-being of you, the institution member. And every effort must be made to design, construct, and manage our projects safely so that we can protect the public and improve the physical and mental health of our engineers, fellow professionals, and operatives on site. In addition to reports, we publish alerts, either because there's been a pattern of similar reports about a topic or in response to a significant failure or collapse event which has been reported in the public domain. And we'll give one or two examples here. This is a steel frame where stability relied upon a number of tension connectors supporting the lower floors. And shortly after 40 personnel had left the site, and without warning, there was a catastrophic collapse. So this was a near miss. The trigger was not determined despite extensive investigation, but it was likely that some of the tensile components in the structure had been involved. And there are echoes here of the 1981 Kansas Hyatt Hilton disaster in America due to the tension failure of a hangar, and that resulted in over 100 fatalities. Now, as with all alerts, there's general advice given, in this case about complex steel frames, but also, as with comments on our reports and in all alerts, we never apportion blame. Now, this was a bridge of unusual design, which was being constructed in an unusual manner. The main 50-meter span was precast concrete truss. It was in position when cracks started to appear over a support node on the left-hand side. And over a period of almost 3 weeks, they visibly worsened with nobody paying any significant attention to them, and collapse occurred. Now, Cross is very concerned that collapses of bridges during construction still occur because such events were the catalyst for SCOS way back in 1976. So we published an alert on this bridge failure along with our colleagues in Cross US, and it draws attention to matters which should be considered at all parties involved in design and construction, not just those involved in bridges, and I commend this report to you. Our first alert on fire concerned the fire in a 7-story parking garage in Liverpool, which is shown at the bottom of this picture on the left of the B-shaped building. That's the arena, and in fact that arena is going to achieve some fame next year, where it's going to be at the heart of the Eurovision Song Contest. But just above it is the parking garage, and fire started suddenly, spread rapidly, and 1,100 vehicles were destroyed in the blaze. It was possibly another near miss because there were people parking their vehicles at the time the fire started. So the lesson learned here was the importance of having a robust and fire-resistant frame, in this case precast and in situ concrete, and the lesson learned is the importance in the future of having measures to restrict the growth of vehicle fires. And it's a problem which is likely to become more acute with the increase in the numbers of electric vehicles. Now, autoclaved aerated concrete is different from normal dense concrete. It is no coarse aggregate, and it's made in factories using fine aggregate, chemicals to create gas bubbles, and heat to cure the compound. And it's weak. When it's reinforced, it is called RAAC, and RAAC planks were widely used in the UK for flat roofs, predominantly during the 1960s and 70s, but a few were used later. Now, in late 2018, we received a report about a sudden failure involving the flat roof in a school constructed using RAAC planks. There was no warning. And although some engineers had known of potential problems for such structures for years, the Cross report acted as a catalyst. It was a precursor. So we published an alert, and then multiple cases of potentially defective RAAC planks were discovered. And one aspect is that many hospitals have propped roofs, and the replacement costs are currently being calculated in the millions, if not billions. And this was a statement recently by a government minister, and clearly we would be concerned about immediate collapse, but hopefully the measures which are being taken at the moment will prevent that. But it's a very good example of Cross at work. A report is received and published, more reports follow, an alert is published, and then multiple cases of potentially dangerous structures are revealed so that action can be taken. And we always have a few alerts in the pipeline, and currently one of them is computer modeling on structures. We've had quite a number of reports about issues with people understanding and operating properly finite element systems. We are concerned about aging concrete structures for a variety of reasons. Competency is very high on the agenda post Grenfell. And then on the fire, going back to vehicle fires, battery fires are a potential risk in the future, especially from automobiles. So at any time, if there is an event in the public domain from which we feel lessons may be learned, then we will produce an alert. Now, very, very briefly on the climate emergency, it's obviously the biggest challenge facing humanity, and there are huge impacts on structures and on infrastructure. So there is a relationship between climate emergency and safety, and we know that we must learn all the time about the destructive effects of these changes and the need to provide protection for both people and the resilience of our structures and infrastructure. We also know that we must reduce the carbon footprint of construction. So there's a climate emergency page on our website, but we need a lot more input. We need more reports. So perhaps you can help if you know anything to do with a structure or infrastructure which has been affected adversely by climate change, then tell us about it so that we can learn more, because matters are only going to get worse. And on the bigger scale, we believe that there is a need for Cross around the world. Sharing information from confidential reports is the goal, and having an international network of communities based on Cross principles will help everybody. The value of such a network has been demonstrated by the International Confidential Aviation Safety Systems Group, which is a bit of a mouthful, but that's established by NASA, which promotes interaction between aviation safety groups around the world as an effective method of ensuring aviation safety. Now, in due course, it's the aspiration that Cross International will become an arena for global discussion. We will identify trends, and it will become an international depository of knowledge about safety in the built environment. We see structural collapses in many countries, but this is a major one, which is in the United States. This is the Champlain Towers collapse, which happened in June 2021 with almost 100 fatalities. Reinforced concrete structure, 40 years old. Now, the investigations are being handled by NIST, which is the National Institute of Standards and Technology, and it's the most complex forensic investigation which has ever been undertaken on a building. The recommendations from that will be published in a year from now, or possibly a bit later, and they're going to have a profound effect on the way we think about aging buildings. These will affect not just the states, but the international community, and certainly what we are doing in this country. So here's the international network at the moment. It first started in Australia, then moved to New Zealand. So that's Cross Australasia. Then it opened in the US, and currently negotiations are taking place with Proof Engineers in Germany. So that will be the next one. And we hope that other countries will join. There is certainly a lot of interest. So to find out more, I hope you'll see this slide or variation of it another couple of times during the course of this morning. If you've not already done so, we'd like you to sign up to CROSS. It's easy, the resource is free. So you just look up cross safety on the website or photograph that diagram on the right and scan it. If you register, then we will be able to send you the details of our newsletters. And the last newsletter was in fact published yesterday. So it's chock full of interesting and important information. So you will benefit by being a member of the CROSS community. And we hope that you will then submit a report or reports, because those are the oxygen on which we survive. And hopefully after this webinar, we will see a spike in the interest from subscribers and we'll see more reports.